Okay, so our slope problems begin with problem number 1, which has this slope right here. And it's going up and to the right. So we already know before we start anything else, we know this is going to be a positive slope. So if we don't get a positive number, we know we did something wrong. Okay? And to do this, we could do it one of two ways. I'm going to do it the hard way, the first problem, and I'll do it the easy way for all the remainder. So the first thing we have to do is if we have these points. So we have this one here looks like point 2, 1. And this point here looks like point 1, 2, 3, 1, 2, 3, 3, 3. So our slope is just rise over run, which is also y2 minus y1 over x2 minus x1. So if I call this top point, x1y, or I'll write it right here. This one is I'm going to call x2 y2, and this one I'm going to call x1 y1. Then I just plug in these values. The m is equal to, that would be 3 minus y1 here is 1. And I'm going to put that over x2 is 3 and x1 is 2. So 3 minus 1, is 2, and 3 minus 2 is 1. So our slope is going to be 2 over 1, and just to reduce that, anything over 1 is just itself, so the answer is 2. So our slope for this first one is going to be 2. Okay. The next one, this one is a horizontal line. So even without worrying about the points, we know any horizontal line, the slope equals 0. Problem number 3. Before we even start, we know we're going to get a negative number because this goes, as we go from left to right, it goes down. So if we don't get a negative number, somehow we did something wrong. And this one, again, to make it easier, what I'm going to do is I'm just going to, instead of using our formula here, which is it's right, but instead of using that one, I'm just going to use the formula that m equals the rise. How much do I go up over the run? How much do I run to my right? So I'm going to put the first point. We'll figure out actually, let's do it in colors here to make life a little easier here. How much do I rise over? How much do I run? Okay, so my rise from here to here, I rise, well, I don't go up, I go down. So this is -1. And then doing it again, that's -2. From this point to this point, I go down -2. And how about how much do I run from this point to this point? I run from here to here 1, 2. So if I do this out, I would get that this is equal to, this whole thing is going to be equal to -2 over 2. Which if I do that out, a negative over a positive is I'm going to get my m equals, okay, it's going to be negative. And 2 over 2 is just 1. So my slope is going to be -1. Now, once again, we started with this point up here and went from this point to this point. What if we had done it the other way? Would we have gotten a different answer? Well, let's see. How much do I rise? From here to here, I rise 1, 2. So if I do it the other way, we'll do it over here. M equals, my rise is going to be, in this case, 2. And how much is my run? Well, my run from here to here is going to be, how much do I go to the right? Well, I don't. I go to the left. So that's -1, -2. So that would be -2. And so doing that out, a positive over a negative is a negative, and 2 over 2 is 1. So once again, I get that m equals -1. So it doesn't matter which point I start with and which point I end with, as long as I'm consistent. So we started with this point. We started with this point and went to this one. We got -1. We started with this one and went to this one. We got to -1. So it doesn't matter as long as you are consistent. Right. Problem number 4 is a vertical line, and we know that any vertical line, the slope is undefined. Because again, it's rise over run, and when we take the run, we're running none. We don't go left or right anywhere. So it's going to be a number over 0. And of course, any number over 0 is undefined. It doesn't make any sense. Okay, problem number 5. Before I even start, I know I'm going up to the right, so it must be a positive. So if I don't get a positive number, I must do something wrong here. And once again, we'll just say that m equals rise over run. All right, so how much do I rise? From here to here, I rise 1, 2, 3, 4. I rise 4. How much do I run from here to here? I run 1, 2, 3, 4, 5, 6. So my answer is just going to be that this is equal to 4 over 6. And of course, 4 over 6, I can reduce that. If I take 4 over 6 and I were to divide both the top and the bottom by 2, that would get me 2/3. So I know my slope is equal to 2/3. For every 2 I rise, 1, 2, I go over 3. 1, 2, 3. Look, there's a point right there. And then from there I go up 2, 1, 2, and over 3, 1, 2, 3. There's another point. Our final graphing problem, problem number 6. Before I even start, I know that this is a negative slope because I'm going down and to the right. From the left to right, I go down. So if I don't get a negative number, I'll know I made some sort of mistake. And again, I could always just plug in the numbers like I did for problem number 1, but to me, the easiest thing to do is just to say that the slope equals rise over run. Rise over run. Okay, and what is my rise? Well, from here to here, my rise is from like that. I'm going down, so it's actually -1. It's a bad -1. Let's try it again. -1. And then my run from here to here is from here I go over 1, 2, 3, 4, 5. So this is going to be equal to -1 over 5. So my final answer is just going to be that can't reduce that or anything. M equals -1/5. So the last 4 problems, for every one of these, we're going to use the same formula, rise over run, but we're going to use our numbers, right? We've got that m equals y2 minus y1 over x2 minus x1. We're going to use that every time. And I'm going to call this x1 y1 and x2 y2. So now I can just put them into our formula. Y2 is 10. 10 minus y1 is 16. And then x2 is -11. And x1 is -12. So 10 minus 16 is just -6. -11 minus -12, that's -11 plus 12, which just is 1. And any number over 1 is just itself. So our final answer is just m equals -6. We're going to use this same formula for problem number 8, where I'll call this x1, y1, and x2, y2. And again, our formula is just going to be y2 minus y1 over x2 minus x1. And so m is going to equal 1 minus 5. And then x2 is negative 17 minus negative 13. 1 minus 5 is negative 4. Negative 17 minus negative 17 minus negative 13, that's negative 17 plus 13, so that would be negative 4. Negative 4 over negative 4 is just equal to 1. So our final answer is m equals 1. For every 1 we go up, we go over 1. For problem number 9, I'm going to use my same formula, y2 minus y1 over x2 minus x1. And this is x1, y1, x2, y2. So I've got m is going to be equal to negative 18 minus negative 12. I'm going to put that whole thing over x2, negative 11, minus x1, which is negative 20. So when I do that out, negative 18 minus negative 12 is negative 18 plus 12, so that would be negative 6. And then negative 11 minus negative 20 is negative 11 plus 20, that would be 9. And if I divide both sides, or the top and the bottom, by 3 to reduce it, I get that that's negative 2 over 3. So my slope is equal to negative 2/3. For every time I go down 2, I go to the right 3, or every time I go up 2, I go to the left 3. And then our final problem for slope is, once again, same formula. Our definition of slope is rise over run, or difference of x's over difference of y's. So y2 minus y1 over x2 minus x1. I'm going to call this x1, y1, x2, y2. And so I'm going to plug that in. y2 is 9, y1 is negative 14. x2 is 11, x2 is 11, x1 is 1. So put this all together, I get 9 minus negative 14 is 9 plus 14. So put that together, that would be 23. And 11 minus 1 is just 10. So my answer is just going to be m equals 23 over 10. Or if I wanted to call that a decimal, I could also call that 2.3, either way. But for every 23 I go up, I go over 10.